Right, so today's podcast, we're going to do some example problems using specific heat capacity. So I have two examples here, and the first one simply says how much heat is absorbed if 1,500 grams of aluminum with a heat capacity of 0.214 calories per gram degree Celsius changes from 15 degrees to 150 degrees Celsius. So the equation is at the top. Just a reminder, Q is heat, M is mass, C is specific heat, and delta T is the change in temperature. And the way we calculate that is always final temperature minus initial temperature. So in this first question, how much heat is absorbed? Our Q is going to be our X. And then M is simply mass, so 1,500 grams. C is specific heat capacity, which for aluminum is 0.214. And then it is in calories over grams degrees Celsius. And then finally, we're going to have our temperature change, and it's final minus initial. So we're going to have 150 minus 15 degrees Celsius. So with that, notice we have Celsius in the denominator, we have Celsius in the numerator, we have grams in the denominator, grams in the numerator. So essentially our units are going to all cancel out. Grams, grams, Celsius, Celsius. We're going to be left with calories, which is what heat is measured in, either calories or joules. So for this problem, we're simply going to multiply everything on the right-hand side of the equation, and we're going to find that X equals 4,665 calories. Alright, but if we look at sig figs, if we look at everything we started with, this first number has 2 sig figs, our heat capacity has 3, and then 15 has 2, and 150 has 2. So 4,665 is going to change into 4,700 calories, and that is our final answer. Alright, so that one's pretty straightforward. The more difficult ones, and I'll just do this as an example, is if we have to solve for final temperature. Alright, so this question says 142,000 joules of heat are absorbed, so that's going to be our Q, are absorbed by 500 grams of water. Of water at 25 degrees. If the water has an initial temperature of 25, what's its final temperature? Okay? So with that, first thing is, I expect you to know the specific heat capacities of water, and there's two of them. It's either 1 calorie per gram degree Celsius, or 4.184 joules per gram degree Celsius. So because this problem starts in joules, we have to use the 4.184 value for the specific heat of water. And then lastly, we're going to have X minus 25 degrees Celsius. Alright? So on this one, what has to happen is, our right-hand side, the first thing we might say is, what is our unit going to be? And because we want a final temperature, it's going to be degrees Celsius. So once we start doing our math, we're not going to worry about units so much. But the first thing we're going to do is, on this side, we're going to multiply 500 times 4.184, and we're going to get 2,092. And again, this is where the units get kind of funky anyways. It's really joules over degrees Celsius, but we're not going to worry about that. And then that is going to be multiplied by X minus 25. And this all still equals 142,000 on the left-hand side. Okay? So now we need to distribute. So on the right, we're going to have 2,092X minus and 52,300. Right, and again, that's still equal to 142,000. Alright, so we want to get X by itself, we want to isolate X. So we're really going to add 52,300 to both sides. If I add it to the right, I have to add it to the left. So that now our problem is 2,092X is equal to 194,300. Right? And we can divide both sides by 2092. We find that X equals, and let's just do sig figs. If we look at everything from a problem, everything has 3. So we're going to keep 3. So we're going to end up having 92.9 degrees Celsius. Alright? So those are two examples. Other things I could ask you, obviously, would be what's the mass? Or I could ask you what's the specific heat capacity. But I think both M and C are a little bit easier than solving for final temperature. Alright, so those are two examples of just what the math looks like when we use the specific heat equation, which is Q equals MC delta T.